Hi, you're all welcome to part two of the Reinvent Recap 2025. So we had part one last Saturday, and we are going to part two now with an amazing list of speakers. So part one is already available on our YouTube channel for those who didn't get a chance to attend. So I'll just let you introduce yourselves briefly before we start. So I'm just looking at my screen. The first person I see, Girish. Can you just briefly introduce yourself?
Yeah, sure. Yeah, hi everyone. I'm Girish Mukim. I'm AWS architect at IBM. I'm AWS community builder and AWS ambassador as well. So I'm very happy to be here to talk about announcement and hearing from others. Thank you.
Thanks, Vadim.
Yeah, my name is Vadym. Serverless is one of my passions, and yeah, that's why the topic. Happy to join Canadian community after visiting Canada this year and last year for the first time. So thanks for inviting me. Mhm.
Thank you, Elliot.
Yeah, hey everyone. Yeah, my name is Elliot Cordo. I have been working in data software engineering, enterprise and data transformation for almost like 30 years. I'm an AWS data hero, and I am the founder of a boutique data analytics and AI consultancy called Data Futures. And I am in New Jersey, so I am also thankful and feel welcome to join you all today.
And Jeremy, there you go.
Yep. Hey, my name is Jeremy Redmond. I'm based in the US in Massachusetts. I'm the founder at Heliobright, which is a cloud and cloud security consulting company. And I am an AWS community builder in security. And I'm excited to talk a little bit about AWS Security Agent.
Yeah, okay, thanks so much. Okay, so Reinvent this year, we had the event around 1st of December to 5th December, so there were about 60,000 attendees. It's usually the number that we have most of the time, except when there's pandemic. And also, I noticed there were like 2 million viewers. That's really lots of viewers online. It's a big event, one of the biggest tech or cloud events. And then we had so many sessions, 3,500 sessions. I know there are so many sessions. Sometimes to pick sessions is usually an issue, and 3,000 speakers as well. So we usually have pre-reinvent, some updates that come up like 2 months to reinvent or so. So there were 414 pre-reinvent releases this year. And then on the reInvent conference itself, there were about 116 releases. So here we have AWS community leaders here, heroes and community builders, who want to share with us some of the announcements that were interesting and some of the things that you would use to build maybe next year as we get into 2026. So I'm just going to go straight, and Vadim, you can take it away. Yeah.
So yeah, I would like to talk about AWS managed Lambda managed instances, or LMI for short, and I will briefly tell everything that I could find out in this 3 weeks after this announcement. Yeah, we can skip this. So what are the user needs that will be addressed with that? So first of all, we know that sometimes Lambda, we have that discussion at certain scale, it becomes kind of expensive. Yeah, especially if we compare only compute prices with containers, EC2s, Fargate, whatever. So there are a lot of complaints that people switch back to something else, starting with Lambda, and that's of course sometimes the things that need to be avoided. So the first thing, what it gives you is also access to specialized compute options. So you sometimes need some certain ratio of memory, compute, or network, and that's not what you can configure in Lambda. You can more or less configure memory, and everything else will be derived from that. The thing is what I told, optimizing cost for steady state workloads, especially if you have high throughput. And that gives you also access to your EC2 based commitments like compute saving plans and reserve instances that can be like that gives you some reduced price. And also, what will be kept, the complete serverless development experience. With that LMIs, you have the same triggers, basically. You can connect it to API gateway and all that stuff that we love, and there are no shortcuts, especially on the triggers and development experience. So now let's create some of those. So there are two parts how to deal with Lambda managed instances. First of all, you see on the Lambda console, there is this new capacity provider. You need to create at least one, or you can create many, depending on what you need. Simply create new capacity provider. You see I've already experimented. And there are only several informations that is important. First of all, it should have unique name. You see here capacity provider for, I use Java with Lambda, which is quite rare, but I like it. And you need to configure basically three things. Where to run, it will be EC2 instances behind it, where to run them. So you need VPC groups, subnets, and security groups. At best, and 3 availabilities on each. Basically, you configure subnets and security groups, and VPC can be kind of figure out from them because they belong to this. You can use the default one, you can create your own. And you need a role that Lambda can launch EC2 instances. If you use SAM, and I will show you the link with the example, this role will be created for you. And it's basically pre-configured role. You see here the policy, AWS Lambda manages to resource operator, which is already there, and it gives kind of access to everything, to network interface, to everything that's required for Lambda managed instances to do the job. These are basically the all required things to create capacity provider. There are certain optional things like instance configuration. You will find that. So what's there? First of all, architecture, hardware architecture. x86 is the default one. Yeah, if you need, you can use ARM. Then you have instance types. The default one is include all instances that are supported, that not all are supported, that we'll be talking about. But you can say what you include only or exclude only. In this case, this is a comma-separated instance type list. I use here M7 R large and M6 R large. You can do whatever you want. Then you can define auto-scaling behavior. The first parameter is maximum vCPU count per capacity provider. This is kind of a cap. So you don't want, this is more or less cost protection, that it just doesn't scale beyond this vCPU count. And there is also kind of scaling mode. You can use auto, then kind of a capacity provider will figure out how to scale out as long as you didn't reach this vCPU count, which is optional. You can say, I just scale out as a hell. Or you can say here, currently it's only CPU policy, like if there is average utilization across all instances of 70%, then please scale out. Everything is here optional because there are defaults. You see x86 include all instances, no maximum vCPU count, and auto scaling is a default. Now we are done with the capacity provider. Now we need to use it when we create a Lambda function. And you see, if you create the new Lambda function, now at these additional configurations, you have a choice. Lambda default, which is the normal Lambda, which we know. And now we have new Lambda managed instances, which means that, now we can simply say we would like to use that instead. And that's basically it. Now you can configure capacity provider. Yeah, that's the only thing. The first one, we need kind of IR of the capacity provider, which we can configure. And there is an optional maximum concurrency per execution environment. It depends, basically, the default values depend on the programming language. For Java, it's 32. For Net, I think the same. The Python can be 16, so figure out the documentation, but you don't need to touch it. And then you should give a hint what instances should be launched depending on currently memory vCPU ratio. Yeah, you can say this 2:1, or you can have kind of other types of instances, 4:1 and 8:1. This is the only configuration now. Memory to CPU ratio, no bandwidth and all that stuff, but you can define the instance types that may support the bandwidth. This is the first thing, and you need to define the function scaling. So minimum execution environments and maximum execution environments. So just, you can say on one minimum and 3 maximum. The catch is here. I will be talking a bit later about that. So that's kind of also how to scale out, basically. It also depends on your max vCPU, what you can get here, that it plays together. So basically, if you then deploy your function, that what you will see if you go to your normal EC2 console, that there are EC2 instances running. You see M7R have been started. And you see the operator is Scala, Lambda, and so on, the name. So you see that it's basically Lambda managed instances. You cannot stop them. Yeah, so you don't have any permissions to go to even to access the instance. So there is nothing that you can do. You are not managing them. When you create capacity provider, you have a bit more things here. For example, the monitoring. Yeah, this is capacity provider monitoring. You see here capacity provider CPU utilization, memory utilization. You see execution environments. You see the instance count per instance, so that you see you can have multiple Lambda functions assigned to different capacity providers. For example, you can have the serverless application which needs more memory-bound instances, then you create capacity provider for that. Another application can have something CPU bounded, then you create the capacity provider with the instances for that. So you can have multiple and assign multiple, and you will have here a very good view on that capacity provider. Also, you can see attached Lambda functions. I have only one small application. I will share more or less post product and get product by ID, and you see that exactly those two Lambda functions are assigned to this particular capacity provider, and the state is live. So what's not supported currently? As you know, these are more or less not firecrackers behind that. These are normal EC2 instances. There is no snap start for that. Yeah, snap start is for Java, Python, and .NET, and this is for Firecracker. It's Firecracker micro VM snapshot technology. For EC2, it's not applicable, but it's not required because the instances are pre-provisioned. There are no cold starts. They are already pre-deployed with the application ready to start it. But if it auto scaling happens, then the instance needs to come up. So you can have, you need more, maybe to scale aggressively. So the same discussions that we have with basically with containers. There is no provision concurrency and reserve concurrency for the same reason, because there are EC2 instances and not micro VMs. So there is no possibility now, until now, to switch between Lambda default and Lambda managed instances. Yeah, it is deliberate choice that you need to meet then you start, because there are different concurrency models. Yeah, you saw with LMI you can have multiple requests per EC2. The default one was 32 for Java applications. With normal, you have only one as a function as a service. Yeah, so that's completely different. Of course, you can later redeploy simply your application to normal Lambda, but there is no switch. And there is currently no possibility to cost effectively set up LMI for staging and test environment with low consumptions or test only. You would like just to set up environment, do the test, and go out. The only thing how it currently works, that if you don't want to pay, is to set this min and max execution environments both to 0. Then the function is kind of deactivated if the capacity, if that's the function scaling values, and then you cannot invoke it. If you invoke it, you get the error. So the only thing is just, if you don't want to pay, to say both to store both values to 0. And then you will start using them. You need to redeploy your stack with minimum 1 and maximum 2, do your test, and then come back to zeros. This is kind of not very convenient. I personally would like to have minimum as 0 and maximum as much as I want, and then the things will go down if I don't use them. It will be more convenient for me. Currently, this doesn't work like this, and it takes several seconds to redeploy the state if you have min and max as 0 to some state that you can invoke Lambda functions. So it's just not pay-as-you-go experience, but with EC2s, it wasn't meant to be probably. So not all instance types are currently supported. So there is no GPU support now, no GPU-bound instances, and there is no T-family support. So this cheaper one, Ts, I could not start them. There is minimum RAM for function using Lambda managed instance is currently 2 GB. It's kind of a big one for me. I could run a lot with half of gigabyte, And if you're using other languages, programming languages, even less is possible. So it's kind of a big restriction currently. In this maximum vCPU count that you can set is also kind of depends on how you can give more memory, or you can select the instances that have more memory. This maximum vCPU count on the capacity provider limit can only be set accordingly to this value. It cannot be below it. It should be at least 2x factor. So I have 16 here as a value. I could not set 8. I need to find out what's the minimal one. The pricing, request charges for Lambda applies as for normal Lambda, 20 cents per million requests. But then we don't have this GPU, this memory to duration ratio. We have normal EC2 charges, instance charges, where the reserved instances available planes will be applied, and there is on top management fee of 50% for EC2 pricing in on-demand state, which is very important. 15% on top for on-demand price. So the no reserved instance pricing is for this second option applied. So use cases, once again, high traffic, steady state workflows, especially high traffic, performance sensitive application. We don't want to tolerate any call starts, and you don't want to deal with snap start and others if available, and cost optimized applications because you can have private pricing, reserved instances, and so on. So this is the link below to my GitHub repo where I experimented with Java 25, but especially with AWS SAM. So you have infrastructure as code to do it. If you use another programming languages, then the same part, the AWS SAM part, can be basically copied. Very easy to set up, and it's supported. Also, CDK is supported, Terraform is supported, CloudFormation is supported, along with SAM. And that's basically it that I wanted to share.
Thanks so much, Vadym. Girish, you can.
Yeah, sure. I'll just share my screen. Just give me a minute. Right, so I just give some I just want to talk about few of the announcement. Before that, right, I'll give you the context, right, where this announcement is really making sense in one of our use case which we were struggling last year, right? So I'll just give a brief. I'm talking about one of the application which is hosted on premises. We were migrating them to AWS, and it is impacting every household in Ontario almost, where they are sending e-meter reading every 1 hour. Right, and then this application processes that and then helps LDCs, which is the local distribution centers, to make the invoice for them and send it to the customer. Right, so that's how the impactful this application was, and they have a big footprint for Oracle databases, 40 terabyte databases they are hosting in on-premises, and we are migrating them. Right, so we looked at AWS RDS, then Amazon RDS, then we looked at Amazon RDS Custom. We choose RDS Custom, which is same like Amazon RDS, but it gives the access to the server. DBS can log into the server, they can see database running, they can do OS administration for there. That is compared to RDS, it is little more flexible in that sense, right? But it is offloading little work back to the database team. Right. So one thing which we are working on is they are having 40 terabyte database today, right? 1 hour frequency for gathering all the meter readings. Now they are planning to do it 15 minutes. So 4 times what is happening right now, whatever current volume. So it is expected to go even beyond 40 GB, 40 terabyte, right? They have projection in a year or so, it might touch 80, 100, all this projections were there. And they were a little concerned about okay, you are saying 64 dB is TB is a limit, then what happens after that, right? So there are concerning factors from client. We had a discussion with AWS and all that, right? But we are limited there. But we are we still were okay with 40 TB, so we just decided, okay, let's go ahead, and then they have future roadmap to increase it further. So that was one thing. And second thing, second issue was they have a big processing happens every quarter. They called it merge processing, where they created indexes on the tables, right? If you are aware about how indexes are helping for performance, right? That's what they were doing. Create indexes, do that merge process, and delete those indexes later, right? But in that case, in on-premises, they were able to create new disk, attach to that, create indexes there, do their merging, and that's it, right? Remove that disk, and they are getting storage reclaimed. And that was a challenge in RDS custom as well. We couldn't add additional storage. We cannot go above 64 TB. There is only one EBS attached, which comes by default, and there is no way we can attach another one, right? So that was a constraint we accepted as a risk, and we moved ahead with that, right? And I'm very happy for the client now that the AWS came up with this, where they're allowing now for scaling Oracle database to up to 256 terabyte. That is a huge leap from 64 TB, right? That is 4 times like storage they are allowing now. And with addition to that, they are allowing 3 more EBS volumes, which we can attach to the server. So we can mix and match. We can have a high performance IO2s. We can have GP3. So that is like good for even other workloads as well, right? Here, like they are needing for index. I'm sure like they are going to love this. I shared this with client, and they were really impressed with the speed what with Oracle Oracle support from AWS came up. So yeah, so this is like I want to just touch base on this, how my client got like benefited with this, and I'm sure like others will also see value in that, right? So this is as I said, this is for large size relational database which is supporting Oracle and SQL Server today, right? It supports 256 terabyte of storage, and then zero downtime. This is a beauty to it, right? You can add EBS volumes on the fly. You can remove this on the fly. Definitely from application side, you need to manage it. It should not impact like your application in a way where when you are removing it. But if it is like if you just want for certain workload, which can really not depending on the existing one, definitely is a good fit. And indexing, which I just said, right? If you're controlled way, you can delete the indexes and then remove the storage. You are reclaiming storage back, not paying for larger storage size. And again, like it is like you can reduce the cost because you can mix and match. It's not like EBS which are attached has to be certain same type GP3 or IO2. You can mix and match. That is adding to the flexibility what clients can get out of it. And it is globally available. It's almost all regions they enable it right from the get go. So it is good news for clients. Yeah, so this was like what like helped what is going to help client when they are doing this merge processing, which I just said, as well as scaling beyond their 40 TB storage currently, right? But when we are working with client, right? So their application stack it completely on EC2s. They have messaging layer, which is like we migrated them from managed Kafka to manage self-managed Kafka on premises to manage Kafka, which is MSK service. And for Oracle database layer, we re-platform them from self running on the server to platform, right, which is RDS. Right. So when we are doing like cost optimization for them, like reserving, because this is long-term like a solution what they are building, right? So we are looking for options to reserve the capacity. So it is EC2 was fairly quick, right? We just told them like there is a reserved instances, there is savings plan. Savings plan is having a little bit more flexibility, but we are having a issue when this same thing cannot be offered in databases, right? We said like, okay, database, you only have reserved instances. So where you are missing that flexibility, right? Reserved instances, you can only reserve certain instance. For example, M6I 12x large, right? So you are tied yourself to that particular instance family. You cannot have any flexibility in that, right? EC2, they are seeing that value where they get the flexibility. They can change from between families, right? So there was like a little bit flexibility when it comes to reserving EC2 capacity, but we are really tied our hands when it's like coming to databases, right? So that is something like, yeah, client needs to get adjusted, right? Okay, like this is from AWS, we don't have that flexibility, so let's go with reserved instance. We went with reserved instance for 1 year capacity, and that's how they are saving today. But come this announcement, right, this database savings plan, they are really like going to optimize their spend, right? After 1 year, we can help them better, where we can say, okay, instead of like reserving this particular instance, why not go with database savings plan, right, where you have a bit more flexibility. So that's when like I see value in this announcement, right? They are going to save like around like up to 35% of their existing cost, which again is 1 year commitment. I don't see 3 year commitment as it, right? It will be awesome like if AWS comes up with 3 years commitment as they do for EC2 instances. So, but yeah, that might be coming. But for now, it is like 1 year commitment where you can save using database savings plan. It's not only RDS. Here I'm talking about RDS use case, but this database savings plan is applied to other databases as well, like Aurora, RDS, DynamoDB, Elastic Cache, DocumentDB, NeptuneDB, Keyspaces, TimeStream. And I do see DMS. DMS is database migration service, not at exactly databases, but they included that in database savings plan as well. And there was really awesome session which happened in part one, where Sam talked about like how this is going to help us to reduce the cost. I touch base in this because I have a use case where customer I just explained, but you can refer that part one and learn more about like how this can reduce your cost for compared to reserved instances to savings plan. Right. So yeah, it is flexible. It is, you can have it in multiple other regions, right? It like and you can have provision as well as serverless. A lot of flexibility came, which is really good. Like when they announced this, and I'm hoping like 3 years also will come down the line. And you have this smart paling tools from AWS, which is like many of us are familiar, right? Like AWS Cost Explorer, or even when we are like doing purchases, right? There is a purchase analyzer. It is there for EC2s as well, and it will be there for database, or it is already there for databases. So you can just see what is running in your workload, what is like recommendation for from AWS for buying reserved capacity. So that is going to help, right? When we are doing this for EC2s, we use this a lot for savings plan purchase analyzer. So you can make use of the same known way of purchasing or understanding what you should be benefited with the purchase, right? So you can use this. So these are the two like basically like announcement which I saw around RDS, which is like interest to me. And one more like this is not related to RDS, but I see this as a really something which AWS definitely going to build more on this. And as like AWS enthusiast, right, it's good for us to know this particular announcement and help our client. Now it is a fact, and AWS is like almost aligning themselves with this, that like workload will run in multi-cloud, right? No one like want to go only on AWS 100%, only on Azure 100%, or same for GCPs, right? So that's when this multi-cloud announcement from AWS is going to make sense to our clients. So what they are saying is it is AWS integrate multi-cloud. So what is happening essentially, we know like AWS, when we are like, for example, CloudFront or whatever service which uses AWS backbone, right? Those are really low latency use cases. So similarly, if you have your workload on one like cloud, which is AWS, and you have your part of workload where you need this integration is sitting on say Azure or GCP, right? So this is going to make a lot of sense to use this particular service where they will have a backbone connectivity between these two environments. So it is AWS as well as GCP today. They announced already this availability for this particular CSP, which is Google. But eventually, like they have a plan to expand it to more like service providers, including Azure. Like Azure is expected to come in 2026. If you see that, like like currently I see that as a good thought around from AWS to make this as a offering, like not locking customers in one of the like their own cloud, but enabling customers to have multi-cloud strategy, right? So it is going to work well for our mutual clients, right? AWS as well as service providers or consulting companies like ours. So yeah, so this is fully managed multi-cloud links. I don't know the nitty-gritties of it as of today. I haven't used it, but I found this interesting to share with the larger community. And like in 2026, we see like more adaptation of this. So let's see how that goes. So it integrates with AWS networking. We know like transit gateway, direct connect, VPC. We are familiar with that. So we still will continue doing that, right? Still using the same networking. At the same time, how this is going to connect with, for example, GCP, where construct is a little bit different, right? VPC in AWS is like regional. But in Google or GCP, it is like not regional construct. They have a global construct when it comes to VPC. How that is going to pair together, interesting to see, but definitely a lot of value there for our clients. So public preview is announced, and there are 5 regions which are unlocked for this, and for Google Cloud support, which I just talked about, and Azure is expected in 2026. So let's see how this goes, and we'll learn more as like clients start adopting this.
Thanks so much, Girish. Thanks for your contribution. I hope now those who will be speaking at reInvent also can now mention other clouds names in their slides because I
Yeah.
that was forbidden. From the multi-cloud is on the way
Yeah,
now.
it's a big shift I see from AWS side, right, where they are opening this multi-cloud connectivity. Yeah.
Okay, sounds good. So Jeremy, you can take over now.
Share my screen. Yeah, so what I'm going to talk about is AWS Security Agent, which was a new launch announcement at reInvent. It's currently in preview, right? So there's going to be certainly a lot of kind of growing pains and things that come as time goes on. Um, we had the introductions a little bit earlier, but just again, my name is Jeremy Redmond, founder at HelioBright. We help teams basically modernize on AWS and Azure with security and identity as a foundation. A third year AWS security build community builder on security as well. So what we'll look at and discuss with the security agent is really a number of things. The three core security capabilities that make up the product, the security requirements that are essentially the kind of back-end foundation for those three capabilities, and then kind of go into the three capabilities, which are the design security review, the code security review, and then finally the on-demand penetration testing. So again, the three core capabilities here with the AWS Security Agent are the design security review, which is essentially it's like having a robotic agent that is your architect doing the review. So, we've all been a part of architectural reviews when you're looking to kind of deploy an application. And what this lets you do is take a architecture document, upload it to the security agent security review section, and then it will review the design you have provided and compare it to the either built-in requirements AWS has or your custom requirements, and then basically spit out an answer saying, hey, these are compliant, these are non-compliant, or we don't have enough information, essentially. So you can use that to kind of go back and keep building with your security, your deployment to ensure it's secure when you first deploy it. The second item is the code security review, which basically is an agent that will connect in currently to GitHub and analyze as you push code, as you do a pull request. It's going to go ahead and look and see and compare against those security requirements and see, do we have something in here that is insecure? Are we hard coding secrets? Are we, making something public that we shouldn't? And it's going to tell you and give you basically information on what it found and allow you to correct that information in the code before it's released. And then finally, we have on-demand penetration testing, which is the capability of having essentially a agent, a robot mimicking a human pen tester and looking at your application and seeing, doing analysis to see are there any vulnerabilities here, what things are missing. It's kind of a great tool to be used in between, a more kind of full scale penetration testing from a third-party company. So again, kind of what I talked about, the foundation for all three of these capabilities is the security requirements. So you have really two main types here. So you have the managed security requirements. Those are the ones that are basically provided and maintained by AWS. So you're going to have kind of the foundational best practices, OWASP top 10, those types of things that's going to build from. And then you can essentially design your own custom security requirements, and those would be maintained by your organization, and you would use those to basically set what unique kind of requirements you have within your company, whether that's certain tagging requirements, certain I need to meet CMMC or PCI. I need to have a certain number of load balancers, whatever it may be. It allows you to kind of specify your custom requirements and build from that. So the first main thing I talked about here is the design security review. So really what that looks like is you take a document. There are a number of file formats supported. Currently, doc, docx, some picture formats, TXT and Markdown. You take that design document, upload it into the design review, give it a name, and it spends some time analyzing that document, and it will basically spit out a number of recommendations. There are limits currently to the number of files you can have. So basically, you can have up to 5 different files within the security review itself. So if you had separate documentation for front end, back end, that kind of thing, they can't be over 6 meg in total size. And then kind of like I mentioned before, it's going to kind of spit out 4 statuses, which is compliant, non-compliant, insufficient data, or non-applicable. It's kind of nice because it allows, even if you don't have a detail outlined in there where it will tell you insufficient data, it allows you to kind of go back and say, okay, you know what, we did kind of miss talking about this, certain piece of a security framework that we really need to make sure is in here. It allows you to go back and adjust that. So this is kind of what it looks like here. Basically, you go in, you start a design review, you give it a name, upload your file. In this example, I have a Markdown file. It spends a little bit of time analyzing the data, and we'll compare it against the managed security requirements or your custom security requirements. In this example, I have the managed security requirements. You'll see here on the right. So there's basically these 10 different categories it's going to look at. And it's going to spit out whether it is compliant, like I said before, not applicable, non-compliant. And if you drill down into one of these that are non-compliant, you'll see here on the left an example of what it looks like here. So you'll see that it's basically identified in the document that the document stated we're only going to use MFA for administrators, and it's saying, hey, well, we're leaving other privileged service accounts wide open here. We're using other roles that potentially could use MFA, and it's recommending to remediate this. And the second main kind of a pillar here, the category here, is code security review. This is where you have this agent authorized and built into GitHub. So right now it only supports GitHub. You essentially authorize AWS to deploy the requirements in your GitHub repo. You can basically select all your repos or certain repos. It will authorize whether it's a user or organization account, and then it will basically be ready for when you do new pull requests. It's going to analyze that code and see if something is not secure or not compliant. And it kind of looks a little bit like this. So this, if you were basically deploying some code here, you're doing a pull request, it's going to pick up that in these additions here, it found some things that are, that essentially should not be publicly readable. And it's making recommendations here to how you can resolve it. And so that allows you to go ahead and fix that before rolling this out and potentially having something that is insecure, out in the world for your production application. And then the final main kind of category and pillar is on-demand penetration testing. So again, this is kind of it's a AI agent that mimics the capabilities of a human tester. You would specify a website URL. You need to essentially do domain verification so that you can prove to AWS that, hey, I'm allowing you to do this, which is important. And if your DNS is hosted in Route 53 in AWS, it will automatically do that approval for you. And then it will go in and do a penetration testing against the application and give you a report on the items it found that were vulnerable. It'll show what steps it took, and it'll give you details on essentially how to improve that, how to fix that vulnerability, and so that you can go in and make those changes. So it looks a little bit like this. So this is a test run here against a website, and it's going to pull out a number of findings and categorize them. Critical, high, medium, informational, the kind of typical things you see out there in industry today, and then show you the risk types. And then it's going to actually show you what endpoints it discovered through the penetration testing and analyzed. And then you can basically go in and see exactly what information it found and get deeper information on what it did. So it's going to go in and it's going to tell you in the summary, this is the chain of execution I took here. These are the things I confirmed and identified, and these are the steps I took. And then it tells you the attack vectors identified, the evidence it found, and will give you details on how you can resolve it to go back and resolve these kind of insecurities within your application. In terms of is this going to replace pen testing companies? Who knows? Time will say, but I think it's a great kind of in between tool to use where you have maybe a medium-sized, mid-sized company, smaller company, where you don't have the opportunity to pay for pen testing or not as frequently. You can kind of run this in between your pen tests to kind of make sure you're better ready to go when you have your kind of full live pen test with a company that does that. So basically, really, in summary here, this is it's a frontier agent that really has kind of three core tiers to it, right? So it has the design security review. So really, you're getting kind of the full life cycle of an application. It's looking at the architecture you put together and you propose. It's going to go and analyze your code that you're pushing out as you're looking to deploy your application. And then finally, it's going to look at do penetration testing against it as you're running that application. So it really gives you that full life cycle management of the application, looking to ensure it is secure. It's like I said, it's in preview right now. It currently just does GitHub for code review. But looks like it's a really great product, and I think it's going to have its use cases out there. And that's all I had on that.
Thanks, Jeremy. Yeah, okay. It's good to top up security and also automate it so it's a bit faster now. Okay, Elliot, yeah, you can take over now.
Well, I for some reason during conferences or meetups, I always end up being like at the last. So I'm usually like I'm in your way of getting like cocktails, so it never fails. So I'm in that position, although I don't suggest anybody, get cocktails before noon. Well, anyway, I don't follow instructions very well. I know we're supposed to cover one service, but I have a little bit of a smattering. Today I was really excited that all the speakers so far, although there was some AI enablement mentioned, especially in the last session, talked about like just general builder capabilities and tools that matter. So I thought that was really cool, and that's what I'm going to do today. As excited as I am about AI, and as important it is to the work that I do with my customers, it's cool to talk about like foundations, right? So I already spoke about me. That's enough about me. So a little bit about my company, just to set a little bit of context. So we are a data analytics and AI consultancy. We do everything from strategy to build, right? So I'll keep it simple since we're a little pressed for time. But just in terms of, I have a large swath of exposure to different companies, different industries, different company sizes, from startups to enterprises. So the first thing I want to talk about is a service that had like a lot of excitement, a little bit of a small start, and is starting to become more and more realized. And being an AWS data hero and a lifelong data nerd, I of course have to talk about this service because it's a good one, and I think it shows a lot of potential. So there were two important announcements made during reInvent. One is intelligence tiering, and what's more boring than like saving money? But no, it's super important, and this is a feature that I hope that folks can take advantage of, as well as managed replication. So before we get started on S3 tables or these two feature announcements, just for those of you who are not familiar with what Apache Iceberg is, it's essentially the new hotness in file formats for the data lake. So for those of you who are not familiar with data lakes, essentially, uh, the primary way that you store data information is through file formats, and there's a long history of file formats, ranging from Avro to Parquet to Delta, which is Databricks project, which nobody really picked up, which is similar to Iceberg, but just saying. And then finally Iceberg, which is, been crowned kind of the de facto standard. And the secret, sauce here is that it's not just the data itself, but also metadata, right? Some metadata files that unlock a whole bunch of capabilities ranging from ACID transactions to schema evolution, right? And why this matters, right? So anybody who's built a data lake, especially in the early days, knows that it's super hard, right? You're basically providing database management capabilities outside of a database management system, right? So you're worrying about compaction and indexing and performance and the management of small files. Super difficult and not for the faint of heart, right? But as these file formats and kind of data lake, supporting services have evolved, it's gotten easier. So now we can actually do almost like OLTP style writes on files in the data lake. And I think, just to highlight another really important thing, which kind of ties back to, some of the other things that were said about like interoperability, such as AWS Interconnect and everything. A lot of data services, hyperscalers, and data clouds have all figured that we're living in a world where there's going to be multi-cloud and there's going to be multiple data clouds and there's going to be multiple systems. And the thing that makes Iceberg really interesting is all of these providers and organizations have kind of centralized on the idea that Iceberg is going to be the mechanism for interoperability. So if you have an organization who runs multiple data platforms, multiple clouds, multiple technologies, the demilitarized zone, the place where you can share data, is going to be Iceberg. And I think looking forward into the future, I think there's definitely a possible future where everything presents itself as Iceberg, right? So a little bit about S3 tables. S3 tables is basically AWS's managed Iceberg service. So it makes Iceberg a first-class citizen within S3. So instead of you like storing and managing this stuff on your side and figuring out how to run compaction jobs, which takes a bunch of small files and puts them into a big file, and all these kind of like DBMS sort of things that you don't want to do, such as snapshots, compaction, AWS does it all for you. And like many things in the AWS ecosystem, it has really tight integration with a whole bunch of services. So you can use it from everything from SageMaker Unified Studio to all the underlying components from SageMaker to Redshift to Athena, etc. Right? So highly interoperable within the AWS ecosystem. So one of the new features that was announced, which was like the natural next step, as everybody thought about, okay, you're going to manage S3 tables for us, but like, are you going to give us ways that we can manage costs like you can in S3? Everybody's familiar with like kind of, the different storage classes in S3, and intelligent tiering, which basically at a slight premium gives you the opportunity to save a whole bunch of money without doing any active management of your files, right? So you can have data that is hot, so things that you've recently accessed, right? Either written or queries. You can have cold data, which are historical partitions, and then you can have archive data, which is barely touched or not touched or not planned to be touched, but is accessible if you need it. So if you think about, a really large transaction table, which has like the full history of your company's data, you can imagine that these kind of like storage tiers exist, right? The reports and the data that people are interacting with on a daily basis, less frequently, and probably not, but it's good that it's there in case like some analyst gets asked for their boss to, analyze data from years and years ago, even though it hasn't been touched in quite a while. So the whole reason this is great is because you can save a lot of money. So if you look at the intelligent tiering options, starting at like basically like the base S3 cost, the further you go into like the tiering hierarchy, all the way down to archive instant access, the more data that you can store in these lower tiers, the more money you can save. And the savings for very cold data is over 5x, right? Which is fantastic. So the second feature that was released to S3 tables was replication, which again was like this kind of concept of a natural extension of S3 tables into some of the feature functionality of S3. And I think that'll continue, by the way. But the really what we're talking about here is AWS managing S3 tables across regions, right? So there's a couple use cases, but really it comes down to probably two things, right? Like minimization of latency. Like so if you can get the data into the region where the people that are going to interact with it are working, they're going to have a better experience querying this data and working with this data. And then, another thing here is, if you have groups that are in geographically dispersed areas, you can replicate data out to them, right? So that way, they can have, the same experience as somebody who's, where the data is created and maintained, right? And I'd say like a tertiary benefit here is non-prod environments, which again, you have to be careful, right? You have to think about the impact and implications of replicating production data into non-prod environments, but it is very often the case with the right controls and policies. It can be okay, but you can essentially avoid manually copying data down to lower environments. You can replicate it, right? But again, I'd say use this one wisely, right? Um, so the only thing to consider with replication costs, kind of in that there's I have a mistype here. There's actually three main factors. One is storage. So obviously, whatever replica you create, you're paying double. There's put costs. So whenever you write data to a region, or multiple regions, you are accruing put costs. And then finally, you've got data transfer out across like S3 regions, right? So these are the three main drivers, and there's a few other like minor costs, but it's probably mostly going to be storage and transfer out costs that you're most concerned with. All right, that's it on S3 tables. Next thing I'm going to talk about is Lambda functions. As was mentioned in part one, somebody spoke about this, but I'll try to, for those of you who didn't watch part one, I'll give a quick overview and also maybe talk about how I'm thinking about it and how I plan on working with it in our study of the feature, right? So I think this is really interesting, Lambda durable functions in general. And the last gentleman spoke about Lambda managed instances. And I think, in general, there's been a lot of like reimagination about what Lambda is supposed to do. Like, and there's a bunch of people that are very religious almost about like what Lambda should do. It should be short-lived. It should be stateless. It shouldn't do all these things that like potentially AWS is now giving us the flexibility to do, right? And I live in the camp that I'm open to the flexibility. Like as long as they keep, kind of the original form of Lambda relatively pure, because I think it's very good at what it does. I don't mind that they expand the features of Lambda and make it work in a more durable way, a more long-running way, or giving people options in terms of what is the underlying compute and infrastructure that Lambda is running. So I welcome these features as long as they don't screw up the OG kind of like Lambda offering. Um, so, Lambda is, as I think a lot of you guys know, intentionally stateless. It's independent. There's no memory, right, for prior steps. There's no guaranteed execution offer. And really, there's no native long-running capabilities for long-running workflows. And I think very often everybody says, okay, just go add a state machine, right? And chain together a bunch of lambdas and services, and that's like kind of the right way to do it. Especially those who are pretty religious about what Lambda is supposed to be and supposed to do. So, but like I think everybody recognizes that this creates like a lot of impedance. Like if you have a multi-step business process, if you need to incorporate some more durability and reliability into your Lambda process, uh, if you need to involve humans in the workflow, or anything that's like long running or asynchronous, you're going to have to lean on step functions. And, that really takes like users out of context, right? And the reason that I think that this is really interesting is as a data engineer, right? When we go and we build things, we like the Lambda model. It's simple, it's easy to understand, it's easy to deploy with SAM. Uh, having to like context switch and think about state language and step functions is not necessarily what we want to be able to do, right? Um, so what durable functions presents is what if you could do this all within Lambda, right? So, Lambda still, is like the processing engine, but what if it could execute like, orchestration and provide durability? So, we could have, step sequencing, we could have automatic retries, we could, most importantly, have persistence between the steps. So they have some internal memory of what came before. And of course, supporting like really like long running executions, which as a data professional, you guessed it, we care about that because like, long story short is usually, like as I said, we like to lean on Lambda. But what I tell people is if you don't have like a deterministic bound for how long things are going to run, even if it runs under 15 minutes now, right? That's too long. Don't use Lambda. Use something else, right? Because what we don't want is for you to outgrow this service and have to like emergency re-platform your pipeline months from now just because you've ran over the ever expanding timeout, right? So what this why I'm excited about this is I think it's going to allow us to use Lambda for even more things, right? Including long running execution. So quick bit of code, and this is right from the AWS docs. Um, what we've done here is like really introduced like a new context, like, and this is the durable context. What this does is it replaces the existing Lambda context and it adds a bit of memory. So there's like some statefulness to the Lambda as well as a bunch of new constructs for orchestration. So you can see here, this is more of maybe like a not so much a data pattern, and but here we're able to do a multi-step workflow in code within Lambda without having to exit step functions. And why would we want this? Really to provide advanced durability and resilience to our Lambda functions and create more advanced workflows and long-running processes without having to leave Lambda itself. So I'm personally excited about it. And what I plan on doing is if you look at a lot of the patterns and kind of the samples that AWS has given you, they're very like kind of like microservice, Saga pattern sort of examples, which are cool. I care about those because I am a generalist aside from being like a data professional. But I'd like to see how we could use this potentially for more long-running data platform pipelines and interacting with a full assortment of kind of like analytic services in AWS, which seems capable to do. I think somebody just has to go out there and kind of forge these patterns and examples. So that's all I got. I would love to connect with you. So there's my LinkedIn QR code.
Thanks so much, Elliot. This is really interesting. We have this recap of Lambda durable functions, which is a very good angle that you brought as well. Thanks so much. The S3 tables, I find that also interesting as they are adding more capabilities to that. So do we have any questions?
Just one question for Elliot, right? Like this intelligent steering we talked about, right? Is it like going to be same like where we need to pay for per object? It might be very less cost, but still, is there a cost involved there?
Yeah, so the answer is that it's just a standard retrieval cost. So like I think the thing you might be concerned about, which is like happens sometimes, is people will set lifecycle policies on S3
Yeah.
and then like something happens that they need to retrieve like a lot of data from archive, even perhaps accidentally, like maybe they're creating like intra-region replication. I think a few people have made that mistake in the past,
Yeah.
right? But the intelligent tiering is just that you pay a little bit of a premium, you walk away from some of the cost savings, but the experience to the users is generally you know the same, right? Like
Okay.
you pay the premium in that you're not getting a full discount
Yeah.
for the storage tiers.
Okay. Sure. Like when we use it, like we just need to see whether it makes sense to go with internet sharing or do it ourselves, right? Based on like use
Yeah,
case. Okay.
exactly.
Makes sense. Yeah.
Same patterns for S3.
Okay,
Yeah. Thanks.
thanks. Good. So we are top of the hour, and I'm really, really grateful for you joining us. It's been a rich session. Our meetups, we have them most of the time, second Saturdays of the month. So next year, we would want you to build with some of these things, and we can always find time to deep dive with more demos, and let's see how to use this to improve the efficiency of our workloads. So thanks so much, Elliot. Thanks, Girish. Thanks, Jeremy. Thanks, Vadym. Happy holidays, everyone. All the best. See you again maybe next year, 2026.
Have a good day, guys. Bye.
Yeah.
Bye.
Happy
Bye.
New Year to everybody. Merry Christmas if you celebrate. Bye.
Merry
Yeah.
Christmas.
Thank you.
And a happy new year. Yeah. Bye.